This is a video tutorial of sections 19E and 19F for HL. I want to start with 19E, and I've got a page from the book, the first page of 19E, here in my notes app. Basically what both of these sections are covering is what the second derivative can tell us about the graph of a function. So we're starting by just reminding ourselves that concave down is this shape. It's a frowny face, so to speak, and a smiley face is considered to be concave up. Now thinking about what the first derivative tells us, the first derivative of a function, this function in particular, f of x equals negative x squared, tells us the derivative, tells us the gradient of the tangent line. So on this curve, we can see that right around here, the gradient of the tangent line is, the tangent line is increasing and it's pretty steep, so it's got a gradient of 2. The tangent line, as we get further down, as x increases, gets a little bit flatter, but it's still increasing. So that gradient is 1, we're told. At the peak, we have a horizontal line, so the gradient is 0. And as we move down the curve, we've got now a decreasing line. We're told that slope is negative 1, and then even steeper. So now the slope is negative 2. So what you can notice about those slopes is they go from 2 to 1 to 0 to negative 1 to negative 2. So the slopes themselves, or the gradients, are decreasing. Gradient are decreasing, which we could see, we would know that because that means that the derivative function is decreasing, because the derivative function is the gradient function. Now, in the same way that the first derivative can tell us if the function is increasing or decreasing, the second derivative can tell us if its previous function was increasing or decreasing. So if f prime of x, or the first derivative, is decreasing, then that means that the second derivative would be negative. Just negative. It would be less than 0. Here is a concave up curve, and we can see the slope at this point is negative. It's because it's pretty steep and it's decreasing, so negative 2. Here it gets a little flatter, but it's still decreasing, so negative 1. Here we have a slope of 0 and a slope of 1 and a slope of 2. So we can notice that we are going from negative 2 to negative 1 to 0 to 1 to 2. So in this case, the gradient of the original curve is increasing, which means the first derivative is increasing. That those mean the same thing because the first derivative is the gradient function. And if the first derivative is increasing, then that means that the second derivative must be positive. So that is summarized right here in this blue box. The curve of a concave down, a curve is concave down if and only if the second derivative is less than 0 on that particular interval, and a curve is concave up on an interval as long as the second derivative is positive or greater than or equal to 0. I'm going to scroll to a different part of notes that I've already written out for you. So the first section right here summarizes that blue box. Again, that the second derivative, or f double prime, is less than or equal to 0 if and only if f of x is concave down. The second derivative, or f double prime of x, is greater than or equal to 0 if and only if the original function is concave up. And that's essentially 19E. 19F then moves into looking at the points of inflection. The second derivative, if it's equal to 0 and there's a sign change, so we'll be doing the sign diagrams for the second derivative. If the second derivative is equal to 0 and there's a sign change, then we have a point of inflection. So let's talk about points of inflection. We've got two types of inflection points. We have stationary inflection points, which we've already seen. A stationary inflection point, it has a horizontal tangent line. In other words, f prime is equal to 0. And it occurs when the curve flattens out but continues in the same direction. So we can see we're decreasing and we flatten out and then we're continuing to decrease. But notice that the concavity changed. We went from concave up to concave down. Here, the concavity also changes. We're going from concave down to concave up, but we are continuing to increase along the way. That gives us a stationary inflection point, and its tangent is horizontal. We could have a non-stationary inflection point. This is when the concavity also changes, but the second derivative, the first derivative is not equal to 0. In other words, instead of a horizontal tangent line, we have a tangent line that's not horizontal, possibly diagonal. And you can see this, how it's an inflection point because we can see that the concavity has changed. We went from concave down to concave up. So this table, which you can also find in your book, is a Venn diagram sort of comparing and contrasting stationary points and points of inflection. The yellow bubble, including the overlapping part, are stationary points. These are points that have a horizontal tangent line, so f prime of x is equal to 0. The gradient of the tangent is 0. And all of these, we can see that dotted line is horizontal. In the ones that are called turning points, those are local max and mins. And we can see that it goes from increasing to decreasing. A stationary point goes from increasing to increasing or decreasing to decreasing. The sign of the derivative doesn't change, but there is still a horizontal tangent line. The blue bubble, including the overlapping part, are points of inflection. So we can have two types of inflection points: stationary inflection points and non-stationary. Stationary, like we just discussed, is where the concavity changes, but the tangent line is horizontal. And non-stationary, we see here in the blue section, is where the concavity changes, but the tangent is not horizontal. So all points of inflection, everything in the blue bubble, the overlapping part included, the second derivative is 0, and there's a change of sign. But for stationary inflection points, the first derivative is also equal to 0, whereas for non-stationary points, points of inflection, the first derivative is not equal to 0. For more on this, I really encourage you to read sections 19E and 19F, but I wanted to give you a verbal audio version of it and somewhat visual to help. So do that on your own.